Hello, Mr. Vessel here today, and we are going to continue looking at bivariate data questions from the AP Statistics exam. And what the task we're going to look at today is one from 2015. It was the number 5 question on this particular exam, and let's dive in today. So, the thing you'll notice, it's a pretty quick prompt here in terms of the amount of reading to do. Basically, we see that a student measured heights and arm spans, rounded to the nearest inch, of each person in a random sample of 12 seniors. A scatter plot of arm span versus height for the 12 seniors is shown. And just like a typical AP Stats display, it's going to be labeled in terms of height in inches and arm span in inches. And you get a quick visual of this display. And the first task is based on the scatter plot. This is always treat these incredibly literally, so we're going to use the scatter plot. And there's not really even any other temptation here. Sometimes with these tasks, you get that computer printout, and you might want to use that. But if it says use the scatter plot, we need to use the scatter plot. Describe the relationship between arm span and height for the sample of 12 seniors. And when doing these tasks, we always want to make sure we cover a couple of bases here. So we want to be able to talk about really 3 things. And those 3 things are like the strength of the linear relationships. We want to mention the strength. We want to mention whether it's positive or negative. And we also want to mention whether it's linear or not linear. And there are times when you might want to mention like a key point, like an outlier, something that seems out of place. Sometimes you want to mention outliers, but this particular display doesn't appear to be any outliers or anything that's kind of a dot that's way off in a weird location. So with this one, we can really do these in really one sentence, and we also have to keep it in context. So apologize for the spacing on this one. There should have been a bigger gap here between the word based and then this let x that should have been moved down. But for part A, really we just want to be able to mention these 3 things in terms of this display here. So some students feel like this one is moderate, and sometimes students say this is a strong linear fit. Actually, in this case, I think either one work fine. And if you ever have a hard time deciding, sometimes it's a good strategy just to merge both of them together. Like in this one, it might not be a bad idea to say there is a moderately strong, and then in this case positive for sure. As the height increases, the arm span's increasing in general. And then the other one that we're going to mention here too is it has a fairly linear pattern. So we're going to do this in one sentence. There is a moderately strong positive linear relationship between, this is where we're going to get it back in context here, that height and arm span. For the sample of 12 seniors. Again, when you see this task where it says describe, describing means specifically mention how strong this linear fit is, if it's linear or not, and then whether the direction of this fit, if it's positive or negative. So part A is a fairly easy task, really. It's pretty straightforward. A lot of times students get partial credit on these because they miss one of these, or they don't put it in context. We want to make sure we always put the context of these things down no matter what the question is. AP Stats questions always have a context, and we should use it every single time. And just mention what, I guess a good litmus test here is, like, if you read this, you could get a picture of what this would look like in your head. So we want to mention the direction, we want to mention how strong it is, and we want to mention what shape it is, in this case linear. So with part B, and this is the part where the spacing of this is a little bit off, but I think this might work okay for us. So it said let x represent height in inches, and we already knew this, and y is this arm span in inches. That was just given in this display here too. 2 scatter plots of the same data are shown. This is the exact same scatter plot, or both of these are the same as what was on the one above here. And we have graph 1, which has the linear regression equation. So this one has an equation given to us as predicted arm span equals 11.74 plus 0.8247x. And then the other graph, this one is just y equals x. So we got these two different lines that are placed on the same displays, and what part B is asking us to analyze is if these criteria described in the table below can be used to classify people into one of three body shapes: square, tall rectangle, or short rectangle. And then they describe each one of these. Arm span is when arm span is equal to height. Tall rectangle is if arm span is less than height, and short rectangle is if arm span is greater than height. And it asks for which graph, 1 or 2, is the line helpful in classifying a student's body shape as square, tall, rectangle, or short rectangle. And I think the key here, let's sort of identify which one's which here. So if we have a person who's square, it means arm span is equal to height. If we just sort of check out this display for a second, you notice this line is y equals x. This is when, let's take this dot here, 64 inches of height. This student was also 64 inches for arm span. So this represents someone who's square, where on this display, it's right here, same dot. But there's definitely a benefit to having the dot right on the line. You'll notice this same here and same here. So really, I think from just checking out this display pretty quickly, the better graph to do this sort of classification is going to be graph 2, and we can say something like, again, the spacing here is a little tough, but graph 2 is better. Oops, graph 2 is better. And the reason it's better is that it gives you the points on the line are going to be the square classification. So we got to mention, it says explain here, so graph 2 is better. Square classification is on the line, and similarly, tall rectangle, that would be if arm span is less than height. So like this dot here, so this person has a 62-inch height but a 61-inch arm span. So 1, 2, these are where the dots are below the line. So that line again is going to be really helpful in identifying those. And then the short rectangle, that will be the dots that are above the line. And we get these dots up here. So graph 2 is clearly going to be the better choice here, where graph 1, you can still do that with a little more analysis, but the line doesn't help quite as much as it does with graph 2. So graph 2 is the right choice because of how nicely it helps sort of fit people into one of these three groups. And then the next part of part B is just completing this table, and actually kind of already done that in this display here. It looks like we got 3 dots on the square classification, 4 for the tall rectangles, and 5 for the short rectangles, and that makes up our sample of 12 students there. And that's really all there is for part B, is just sort of using this 2 different graphs to make some decisions about these classifications for body type. And then the final task is looking at the best model for prediction, and that would have been given to us already. So they gave us this rule. It just asks us to calculate a predicted arm span for a senior with 61 inches of a height of 61 inches. And I'm going to look at this graph here for a sec. So, they could have asked this part C in a lot of different ways, but basically we did have a student who had a height of 61 inches, and it looks like their arm span is 64. But really all they're asking us to do here is just predict. So we're going to try to use this rule and just see what this number is about here. So we got this rule to use, and we're just going to plug in our correct number here. So for our arm span, getting the predicted arm span, and it equals 11.74 plus 0.8247 times the height. And in this case, that's 61. So we're just going to plug in the number 61 and calculate it. And that value is 62.05 inches. And that's all there is to it. It's just using the equation to make a predicted value. And sometimes they could have asked about maybe a residual here, or maybe just an observed value, but they didn't. They went with just using your equation here and make that value for the predicted height. So pretty straightforward, and kind of matches up with what you'd see in the display. Not that you need to check that particular answer, but it seems like it's a little bit above 62 inches for a predicted arm span here. So it's a way to make sure that what you've done seems accurate. And that was it. That was the number 5 from 2015, and hopefully that was informative and helpful in your understanding of bivariate data. So thanks for listening, and comment below if you have any questions.